Good afternoon. Thank you for joining us for this STS-134 post-MMT briefing. Joining us is Leroy Kane, the chairman of the MMT and deputy for the Space Shuttle Program. Leroy?
Thank you, Nicole. Good afternoon. It's good to be back with you today. I think most of you, I'm sure, have heard about AMS, the fact that it's been installed and activated, and I believe Dr. Ting was over to talk about some of the science that the experiments are already producing. So just fantastic news there. A lot of folks are very excited about that, and of course that's what this is all about, so we're all very happy about that. On board, the crews had another really great day. We have our EV crew members are camping out tonight, and the other crew members were working on EVA prep toward the end of the day, and of course we have our spacewalk tomorrow that we're looking forward to. So all things going very well in that regard in terms of that preparation. In the MMT today, we talked about several items. I'll touch on a few of them here. We did get some of our imagery data from the SRB videos, and the SRB open assessment is actually ongoing, but we do have some of the video available now, and it was put out there on the servers for our analysts to look at. And we were able to see in some of the views that they showed us that it looks like we have some, in all likelihood, ice coming off some of the LOX feedline brackets. One specific bracket, the bracket at the 1377 location, looks like it generated some debris, and again, we believe it's probably ice, but we'll go look at it. And it was at about 70 seconds into the flight, and in one case, the debris impacted one of the aft struts and broke into several smaller pieces. In another case, we saw debris impact the starboard landing gear door, and so we think that maps well into one of the damage sites that I showed you yesterday in the graphic, and we'll look at that again today when we get to that graphic in a minute. So we are beginning to get some of that video, and that'll help us complete the puzzle in terms of determining, to the best that we are able to determine what generated some of these damage sites on the bottom of the orbiter. The video will continue to be analyzed, and we were able to just look at a couple of those shots today in the mission management team. The SRB team also reported that apparently one of the solid rocket booster parachutes had a tear in it. We don't know when that happened during the descent. We don't know anything more than it was apparently torn, and so there'll be some post-flight assessment of that as well going forward. In the major item that we talked about today and spent the most time on probably is our DAT team assessment. And when I was here yesterday, I told you that we had 7 areas on the underside of the vehicle on the tiles that we were still assessing. And of those areas, we've been able to clear several of them, and we still have a couple that are open. So if we can go to the first graphic, I think I can show that to you. You'll recall this graphic I showed you yesterday. And we have 7 areas on there, the 7 red dots. The red dots that have the yellow boxes associated with them are 2 areas that I'll talk a little bit more about that are still remain open as far as our assessment. We have not cleared those areas. The red dots that have the green boxes associated with them, the team has successfully cleared those areas, and there's no more work that we need to do on those damaged sites. Those ones are good to go. And so we do have 2 of them that remain open. One of them is kind of in the middle of the cluster there. It's the yellow box labeled 2-001. And so I think the next graphic will show a picture of that one. I actually showed you this picture yesterday. So this is the site that the team is spending most of the time on in terms of the one that's got our interest the most, primarily because of the dimensions of it to include the depth. And so there's some more work that's ongoing in terms of looking at this site. What I wanted to do was to show you some other data that we looked at in the MMT today, to include a damage site that we had on STS-118. Before I do that, if we can go back to the first slide. can we go back to the first slide there? You see the first slide, you see this box, the green box labeled 2-003, where we have a tile that was damaged here. That location is the same location where we had the tile damaged on the STS-118 mission that I'm about to show you a slide on. And what I want to point out is the relative vicinity of that damaged site compared to the damaged site in the yellow box, 2-001. So the damage on this flight, the 2-001, the one that we're interested in looking at in more detail, is approximately 14 inches forward and 11 inches inboard of the site where we had damaged tile on STS-118. So if you can keep that in mind, and we can go to the 118 chart. This is a picture of the damage that we had on the STS-118 mission. Again, as I pointed out to you on the previous chart, you have an idea now where this damage site is relative to the damage that we have on the vehicle on orbit. This is the imagery that we got during the focused inspection that we did on that mission. The picture on the left with the red box around it, again, shows you the location of where this damage was and the tile that was damaged. And then the two boxes at the bottom is a comparison of, on STS-118, the dimensions of the damage to include the length, width, and the depth, the X and Y and Z coordinates, and then the tile thickness. And then STS-134, you can see our best estimate, our current best estimate of what the damage is, and then the same thing, the tile coordinates and then the tile thickness. So we looked at this for purposes of comparing, obviously, the damage we had on the previous mission to what we see in orbit right now. And so relatively close in terms of position on the vehicle, very close in terms of dimensions and volume of damage, potentially pretty similar. And then I wanted to show you one more chart, and this is the STS-118 damage. It's comparing the on-orbit focused inspection imagery that we had to the picture that we took post-landing on the runway. And so it's kind of hard to tell them apart. You can see a little bit more detail in the one on the right post-flight on the runway, because it's a picture that's on the ground with a pretty good camera, and it's obviously got some more color capability than what we have on orbit. But just to give you an idea of how we fared on STS-118 with some pretty similar kind of damage. So we can go back to the chart that has the STS-134 tile site damage. It's the one that's the second chart. There we go. So this is the one that we're looking the most at, and the team has not completed our assessments on this site, but the work we've done so far, we believe that we may need to do a focus inspection in order to get some more fidelity. You can tell the picture is kind of fuzzy. The photo lab folks have tried to do some enhancements on it, but to the best of our ability, the team is trying to understand that from a dimensional analysis standpoint, and then they can go do the structural, thermal, and aerothermal analyses, and that work is ongoing. So, so those were the slides I wanted to show you today. And so with respect to that site, as I said, the work is ongoing. The site that is the other yellow box that's on the Elevon, that was not cleared as of the time of the MMT discussion today, but the team was pretty confident that they were going to be able to clear it this afternoon. So I anticipate that site will probably be cleared. However, The plan that we have going forward out of the MMT today is I've directed the team to go ahead and put the focused inspection plan into work. As you know, we had the placeholder on the crew's flight plan timeline for Saturday on flight day 6. And so the operations team has gone and done the next level of assessment. They have to do the robotics assessment. Once they find out the exact damage sites, they have to go do all the robotics and robotic trajectory analysis. And they've done all that work, and they're building those procedures. So that's the plan that we'll uplink to the crew at the end of their crew day tomorrow. And it'll be a plan that will do focus inspection on those 2 locations. Now, I think in all likelihood, we will download to a second plan that we have, which is to do the inspection on only the one site, the site that's labeled 2-001 in the yellow box, the one that I've spent some time on here today. Because as I said, I think we'll clear the Elevon site. There's also a possibility that between now and the early hours of the morning that the DAT team will in fact clear even this site, the 2-001 tile damage site. They had less confidence that they would be able to do that based on what they knew coming into the MMT today, but they did not rule out the possibility that they would be able to clear that site as well. So in summary, we have some more work to do on a couple of these sites. Pretty high confidence we're going to clear one of them, some possibility that we're going to clear the other one. We have procedures built and timelines built and ready to go to the crew tomorrow morning, whatever the scenario might be for one or both of the sites or neither of them. And if neither, of course, then we won't be doing focus inspection. So it was really a good update from the team today. They're continuing to work very hard on the problem, and we are exactly where I would like us to be in this process. We'll move forward from here, and tomorrow we'll have some more information, and we'll report that as we get it. The other item of discussion that we had today in the MMT was the Soyuz 25S undock plan. As you know, when we decided that we could launch on May 16th, we did that with an understanding that there would be a Soyuz undock occurring while the shuttle was docked. We've done a lot of work with what we call DDO, or dual docked operations, which is to say another vehicle is departing the station in an undock and separation fashion while the shuttle is docked there. And so we've done a lot of work on that for a couple years. In this case, we had done even more work for this specific kind of scenario with a Soyuz coming off of the MRM-1 port as we were preparing to do this undock and fly around on STS-133, which we ultimately did not do. In this case, it's a Soyuz undock from MRM-1 port, but it is not a fly around or even a fly about, as we spoke about on STS-133. It's really an undock with a station attitude maneuver and then some photography ops from the Soyuz. And so from a shuttle standpoint, most of the work that we needed to do to be prepared to go do for the station to go do the 25S undock during this shuttle dock mission, we have already done. And so most of our work was going back and verifying and re-verifying that based on the 25S departure corridor, the trajectory, the plumes, all of those kind of things that we analyze as a matter of course for all of the DDO work that we've been doing, we went back and re-verified for this exact case that we're okay and we're safe and we have the margins that we need to have. And so the team came in and presented that plan today, in addition to an overview of the profile for the undock and the station attitude maneuver and the photography operations that are going to take place, to include which crew members are going to do what on shuttle and station, and what the Soyuz crew is going to be doing. Now this happens on Monday. It happens at approximately 4:30. The undock time is about 4:30 in the afternoon Central Time. So the shuttle crew, the STS crew, will actually be, it's in their sleep period. I'm not going to guarantee that they're all going to be sleeping during that time frame, but it is during their sleep period the way we have it scheduled. And the the team has laid out the entire plan in a way that I think is very easy for us to understand. And we laid that against the work that we had already done for DDO operations, and did a real good thorough review of that today in the MMT. So I'm prepared to go into the station MMT tomorrow morning and tell them that we're comfortable, and barring something coming up between now and then, we'll be, from a shuttle standpoint, we'll be go for the 25S on dock as planned. Now I will tell you that there's a good bit of work still ongoing on the station side primarily. There's a lot of coordination with the Russians in terms of the attitudes and the commands that are required, as well as the power plan and the folks that do the power analysis and the thermal analysis have ongoing work on the station side. That work is not complete. They have to make some assumptions when they do that work. So if in making those assumptions, the analysis for the power and the thermal all comes out good, then they'll be happy to perform the undock with the attitude maneuver and the photo ops that we've talked about. They are continuing to carry their quote nominal undock plan, so that in the event that something doesn't turn out with the margins and doesn't turn out favorable in terms of the thermal or the power plan, they can go to their normal Soyuz undock plan, and in that case we would not see the station maneuvers, and the crew on the Soyuz would not be doing the photo ops, and we essentially wouldn't be doing what we've been planning for. So they're carrying both of those plans forward, and they need to do that until such time as their thermal and power plan comes back and they have all of that showing favorable. I think they feel a fairly high degree of confidence that it'll come back favorable, but just as a matter of course, they're carrying the nominal plan forward for at least another day or so. And so I think where the undock plan is concerned, my understanding is that the station program is going to come tomorrow and do a briefing at 12 o'clock noon local time. And that'll include, I think they can show you a video of what the Soyuz undocked and the station maneuvers and you know, what the photos will look like from the Soyuz vantage point and all of those things of interest as it relates to the Soyuz undock. So stay tuned for that. My understanding is it's at noon tomorrow. So with that kind of wraps up everything we talked about at the MMT today. I feel really good about where we are. The team is continuing to perform at a very high level. And of course, all of the major objectives that we're trying to accomplish on this mission are they're coming off without a hitch, frankly. Couldn't be more pleased about all of the work that's gone into the mission and how it's turning out here for us in terms of the ELC transfer and the AMS. And so we're turning our attention toward the spacewalks now. It's a huge part of this mission as well. And, you know, we put a lot of focus on spacewalks. So we're ready to go do the first spacewalk tomorrow. And with that, I'd be happy to take any questions.
All right. Thank you very much. That was a great update, Leroy. And we'll start with questions. Gina? Or Seth?
Seth Bornstein, AP. Leroy, forgive me, I missed all of yesterday's. I was in flight. So can you go through the timeline of Saturday with the focus inspection? What time are we looking at on Saturday? I mean, will it impinge on the EVA preps for EVA 2? Who will do what?
I can do some of that. Because this is a station operation, I can tell you in broad strokes what the plan is. The timeline is still being refined a little bit, but in general, the actual undocking occurs at 4:30 Central Time, 4:30 p.m. Central Time. Okay.
I meant the focus inspection.
Oh,
forgive me.
Okay. So for Saturday's focus inspection, and again, here I don't have an exact time for you, but I can tell you that the beginning of the focus inspection, where we have it laid in right now, would be approximately, it's toward the end of the crew's morning, if you will. Okay. So, and it's about a 3-hour block of time, I think. We can give you the exact, timeline with all the details on both sides of it, with which crew members are doing what. I'd be getting in front of the ops team a little bit to give you any more than that right now. But coming in here tomorrow, we will absolutely have every detail of that plan that we can show you, and it'll be the one that we uplink to the crew. I don't want to give you any more detail than that right now because I might give you something that would be different than what we ultimately decide to uplink to the crew, and that wouldn't be helpful. So basically, it starts about the middle of the cruise, about the end of the cruise morning on flight day 6. So it's really Friday night, Saturday morning, and it'll be Saturday morning in the early hours of the morning when we start the focused inspection.
And forgive me, since I also missed it, the dimensions of 001, 2-001, length, width, depth.
We could put the chart back up. If you wouldn't mind, put the STS 118 damage comparison chart up. It shows the 118 and the 134.
But I thought that was for 02, the one that wasn't.
This is for 2-001. This is the one that we're most interested in. The only other one that we still have some work ongoing is the tile damage on the Elevon. And we believe we're going to clear that one. So these dimensions are 3.22 inches by 2.49 inches by 0.7 inches. And that's length, width, and depth in that order.
And just for laymen, just what goes on in a focus inspection? It's been a while since I've seen one of those.
Okay. Well, we have some instrumentation, cameras and lasers on the end of the orbiter boom sensor system, and we'll pick up that boom with the shuttle's robotic arm, the RMS, and we'll extend that down below, over the wing and below the vehicle, and we'll look at these areas with both cameras and the laser, and that will give us a very good images as well as measurements, if you will, of the damage site. And it would be, the picture that I showed you earlier of the STS 118 damage was from focused inspection on that mission, STS 118.
Clara Moskowitz with Space.com. And can you give me an idea, sort of big picture, just how often is a focused inspection necessary? You know, how many times have you had to do that recently?
I can tell you exactly how many times we've done it because I asked the team yesterday and they reminded me. We did it on STS 114. That was our return to flight mission. And we had there some gap fillers that came loose, as well as some other damage sites that we were looking at. Same thing on STS 121. That was the mission that followed 114 in the summer of 2005, I believe. So we had that time period where we didn't fly between 114 and 121, which was about 9 or 10 months, something like that. Because we had some more work to do on the external tank as a result of what we saw on the first return to flight mission. So we did some focused inspection on 114 in orbit. We did some on STS 121. In both of those cases, you'll recall that in the earlier flights as part of our return to flight effort, we still had some gap fillers that were coming loose on us because we had been doing the gap filler work as much as we were able to do in each orbiter flow for each one of the return to flight missions. So as time went on, we saw fewer and fewer gap fillers protruding because we were in fact proactively going and replacing them in each orbiter flow every opportunity that we had. So there was a lot of gap filler to look at on 114 and 121. STS 118 that I've showed you here today, we did a focused inspection there. And then on STS 122, I believe, we did a focus inspection for some damage on OMS pod tile blanket area. I can't remember exactly, but I believe it was on the port OMS pod. And so we've done it 4 times, and we've looked at more than one damage site on at least 3 of those missions. This focused inspection that we're talking about here, if we go execute it on Saturday, we'll look at this one site and possibly the site where we have the damage on the Elevon as well, although I think it's pretty unlikely we'll do that one.
Thanks. And also just one more question. To be clear, would you, if you do end up having to do the focused inspection, would you have to cancel any planned activities, or would that just be less downtime for the crew?
Yeah, it's, I talked about this a little bit yesterday. We don't have to cancel any activities. The team has done an amazing job with this timeline because of some of the challenges that we had leading up to the first launch attempt. With getting everything synchronized and choreographed, they had to work really, really hard on it. And then for the second launch attempt, it was even more challenging with respect to sleep shift and adding both of the +1 days and doing that at the outset for the launch on the second launch attempt. They built the timeline and they made changes to it such that we could sort of plug and play most of these flight days. And included in that is the ability to work around something like doing a focused inspection on flight day 6. So they have it placed in the timeline in a place that is probably the most benign that it could possibly be in terms of upsetting the other activities that we're trying to do in the sequence that we're trying to do them in this mission. So we're real fortunate because the team has worked really hard on the timeline and on the plans and on the contingency plans. So we're not going to have to cancel a single thing. And in all likelihood, it'll mean that we'll have 1 or 2 crew members that may have to spend, work a little harder for a couple of minutes on one of the days we're doing transfer. That's about what it amounts to.
Okay, thank you.
Philip Sloss with NASASpaceflight.com. On this site, I realize you don't have as much precision in this as with the 118 site, since you've done a focused inspection on that. But is there a sort of the differences between the two sites? We have a different tile thickness, possibly different damage. Is there any preliminary sort of assessment in terms of whether you'll be able to clear this ultimately with or without the additional data from an inspection, if you need to do that?
Well, it's a good question, and it's an important question, and we talked some about it in the mission management team. As you can see from the graphic I showed you earlier, the dimensions are pretty similar when you compare the 118 damage to the one that we're dealing with here. To include the depth, at least our best estimate of the depth. Some of the challenges, and maybe we can go ahead and put that the second graphic back up, the one that has this damage site. The one that has the STS-134 damage site by itself. I think it's 2A is what it's labeled on the second chart. So what the team is trying to do is to understand what's actually in the white space that you see, the white of the tile here. So there's varying depth, and it's very difficult. They do their best with lighting and shadows and things of that nature to try and determine where the deepest parts of the cavity are, and how those are oriented to the airflow, if you will. And there are some challenges with that because, as you can see, this picture's a little fuzzy. I think we had a little bit better fortune on 118. Even before we did focus inspection, I think we had a more clear picture than this. But at any rate, one of the important factors is, volumetrically, how are the deeper parts of that cavity oriented to the airflow? And then what does that mean in terms of the aerothermal aspect the analysis. So on the 118 case, we had a cavity that turned out to be they had what the team likes to call a shelf. So it had sort of a gradual slope down to kind of a plateau, and then back up in kind of a sharp at the backside of the cavity. This one is different than that, and they won't know until we get better fidelity on the depth dimensions, how much different it is, and whether it's going to be an issue in terms of how the flow will affect the capability of the tile to protect the structure and the systems underneath it. If you took this cavity and you oriented it differently, it might be easier to clear it, just to give you an example. And so while it's similar to the 118 damage area, as best we know it today without focused inspection, there are some differences, and some of those differences are where the deepest parts are oriented to and how they're oriented to the free stream flow. So that just gives you an example of one of the kinds of things that they look at and what would be similar and what would be different. Now, it is possible that through the rest of the day today, they will make some very conservative assumptions about, what we might find in focused inspection, and then sort of envelope the problem such that they could come back and say, well, when we did this, we saw that we had margin in this case, and in that sense, we might be able to clear it without focused inspection. But as of the time we did the MMT, they didn't think, they weren't confident that they were going to be able to do that. Whereas the site on the Elevon with the damage, they had very high confidence they're going to be able to clear that. It's probably already cleared by this afternoon.
Thanks. And the second question is about this. About the 70-second. I guess the first part of it is just, was this a single event at 70 seconds, and did that event cause this impact that's being discussed more thoroughly?
Okay, so yeah, I was talking about the SRB video, and we're just starting to see some of the SRB video, so the team was not able to go through and assess all of it. It's a lot to look at from the boosters. But they did show us a couple of clips. One of the clips is of this debris event from the 1377 LOX feed line bracket, is where the debris is generated from that bracket. And in that case, it's a single piece of debris that traverses down the stack and impacts the aft strut on the tank. And then it sprays into several pieces and you can't tell from that video whether any of those smaller pieces impacts the orbiter or not. I think you can tell that it probably doesn't, but I don't know if you can tell with certainty that none of those smaller pieces impacted. Those smaller pieces of spray wouldn't have caused this kind of damage that we're talking about, even if they did, in fact, impact the orbiter. So that was at 70 seconds. At 70.3 seconds, from that same vicinity of the 1377 LOX feed line bracket, we see a piece of debris coming off and traversing down and hitting the starboard main landing gear door. And we can tell with pretty good certainty from the impact and then the spray, if you will, after the impact, that piece definitely impacted the main landing gear door, and it impacted in the area and caused the damage that I showed you yesterday on the main landing gear door. That was one of those 7 areas which we've subsequently cleared. So those were 2 events, very close in time, in that 70 and 70.3 seconds. Both appear to have been originated, I should say, from the 1377 LOX feed line bracket. We're suspect that one or probably both of them were ice as opposed to foam in this case. And we think that, and they both impacted, one on the external tank strut and the other one on the landing gear door.
Thank you. And then one final one about imagery. Have you been able to go back and find imagery of either ascent imagery of this or pre-launch imagery, for instance, from the final inspection team on that bracket?
Yes, yes, we have. That's another good question. We didn't talk about that in the MMT today, but I do know from my conversations outside the meeting afterwards, in asking a couple of questions, the answer is that we have still photos. Of course, we have closeout and pre-launch on the pad photos and video of all of these areas. And we do have still photos where we have ice formation on those brackets, which is typical on a day like we had, launch day like we had, where it was a pretty good ice formulating day in terms of the weather conditions. Now you'll recall that this ET-122 didn't have some of the modifications that our return to flight tanks have. One of the modifications it didn't have is to those feed line brackets. They still have the older bracket design and not the new titanium brackets. The new tanks with the newer tanks with the titanium brackets don't have the tendency to have ice buildup in these LOX feed line bracket areas like we saw on ET-122. So this was not unexpected in terms of the performance that we expected from ET-122. This is one of the areas where we knew we had some susceptibility as a result of not having that modification in place.
Mark Haro for Aviation Week. Switching to the photograph, can you give us some idea of the perspective that you would get from the current plan of the orbiter? I mean, I guess I'm sort of asking what your perspective in the imagery you get, or do they just kind of go for what they can get?
Well, I can sort of try to describe what you'll see when they bring in and show you the video tomorrow, Mark. They're actually going to show you a video, and it has 3 pictures in it. One is from the Soyuz vantage point. One is sort of a side view of the vehicle, not quite a God's eye view, but sort of a side view of the vehicle, the entire stack to include the shuttle station, the Soyuz, everything before the undocking occurs. And then the other one is the view that you see, just the vehicle along the velocity vector moving around the Earth. And so then they play the video, and it shows you the separation and what you see from the Soyuz during the separation. And then they'll show you the station and how it maneuvers, the attitude maneuvers underneath the Soyuz. And that'll show you the exact perspective from the Soyuz of the entire stack. But basically, we maneuver to a YVV attitude for the undock, as opposed to the normal attitude that we fly around the Earth in, and then do the undock, and then do another station attitude maneuver so that you can get a perspective of the station that includes, so you can get sort of a side view of the station with the vehicles that are attached to it, instead of looking down any one axis or looking more in plane, where you would be less able to appreciate all of the station in all of its glory, if you will. So I can't describe it much better than that without showing you a picture and a video. And unfortunately, I don't have one today, but they'll be able to show you that tomorrow.
Okay, I guess I'll press just a tiny bit. Do you have the Earth or space in the background, or a combination, or is that, we're going too far here? I'm just sort of wondering what the context would be for the image.
I don't recall. I wish I did. But the video's great.
All right, thank you. And Gina?
Gina Sinceri, ABC News. With this focused inspection, are you considering adding a day to this mission? Has that come up in discussions at all?
We're not going to add a day. We don't think we need to add any time into the plan. I did ask the team just in terms of being thorough in the last day or so, we'll take whatever time we need to do this. Is the time that we have planned sufficient? And all the answers came back that we feel very comfortable with what we have timelined and what we had in there as a placeholder. This is a fairly straightforward as far as focus inspections go, in particular if we only have one site to look at. So we didn't feel a need to add any time or certainly not a day to the plan.
Okay, with that, we're going to move to the phone bridge, where I believe we have three reporters waiting with questions. I believe Irene Klotz with Reuters will start.
Thanks.
Okay, I think maybe we lost Irene. We'll start with Bill Harwood with CBS.
Yeah, thank you. Leroy, a couple of questions, and I apologize if you addressed any of this earlier. Had some children issues had to deal with. An obvious question with tile damage is, what are the possible implications? And I realize looking at this, it doesn't look as bad as 118, and you may be able to clear it. But if you don't, can you tell us worst case? This is not a loss of vehicle issue. Worst case, I'm assuming this is a repair issue, and that's worst case. A, am I right in that assumption? And B, if you had to repair something like this one, can you refresh our memories about exactly what the astronauts could do and what effect it would have? And I realize that you're not anywhere near making a decision like that, but I want to make sure I understand what all the options are. Thanks.
Okay, Bill. Well, you're correct in terms of the worry factor on this one. And let me be specific. When I was here yesterday, I talked about the fact that, this is not, I'm not concerned about the damage that we're seeing here. And it's certainly not alarming. And the team is not concerned about it. And again, my confidence is largely derived from the fact that we have a very good process for dispositioning these things. We know exactly how to go assess them. We've gotten better and better at it. And we know that our models are doing nothing but improving as time goes on and we get more experience. And then in the event that we do come up to a point in our assessment where we feel like we need to get some more data, we know how to go do that, i.e. focused inspection, which we're talking about doing now, which we may do Saturday. We still may not do it also. And then when it comes right down to it, if focused inspection and the analysis of the data from focused inspection determined that we didn't have the kind of margins here that we wanted to have, then we do have some options to go do some repair. And Bill, I'll indulge you a little bit, but I don't want to go too far down this path because I have a pretty high degree of confidence that this is not where we're going. But suffice it to say, as you know well, we do have some repair capability. We have one that with some material that astronauts would go out with, essentially like a gun type applicator, and we put some material in the cavity. It's called STA-54. We also have what's called a tile overlay, and we have a lot of confidence in both of those repair capabilities. If we should need to use them, we also have the ability to do some some verification on the ground of different kind of repairs that we're getting ready to go do. So, but that's really about as far as I want to take this discussion, because I feel pretty confident that if in fact we're not able to clear it by the morning, when we get the focused inspection data, that we'll be able to clear this problem and not have to do anything before we can return safely. But having said that, we're going to go do whatever is necessary, and we're going to follow the data all the way along in that process. And in the meantime, we're going to stay very much in the process and within ourselves, and we're not going to get too far ahead of ourselves. I wanted to show you today the 118 case because of the similarities, but also that there are some differences. And but I think the similarities are good to show. And the fact that we did do a focus inspection and the fact that we did determine we didn't need to do anything in that case, I wouldn't be surprised at all if we end up on a very similar path here. In fact, frankly, that's my expectation.
Leroy, you mentioned once again the 118 case, and I remember in that case, John Shannon was telling us that one of the reasons it was cleared for reentry was because of the underlying structure. Can you tell us anything about, in this location, is it similar in the sense of, the heat sink that's involved and all of that? Thank you very much. That's it for me.
You bet, Bill. In fact, let's put up the graphic that shows the entire bottom side of the orbiter. I think it's the first picture we put up today earlier. This isn't the best picture for showing you this or illustrating this, but if you can imagine the line that kind of goes down this starboard side, if you just sort of connect all the red dots on the starboard side of the vehicle, there's an intersection there between the main body of the vehicle and the wing, and so this is kind of in the area where the wing box is, where the delta wing on the starboard side connects to the main body of the vehicle, and so there's a lot of structure underneath this area, and in fact, Bill, to be more specific. And we didn't talk this in detail on the MMT today, but I've asked the team to bring in some more detail for tomorrow's discussion. We think that the tile damage here, the 2-001, the one we're talking about on STS-134, where it's a little bit forward and inboard of what we had on 118, is actually over even a little bit more beefier part of the a little bit beefier part of the structure than what we had on 118. So there's a potential that we'll be able to take even more advantage of that than we were able to on STS-118. And so there really aren't any other systems directly underneath this tile or in that vicinity. And it is over a pretty significant part of structure. And so the team, as we left them today, they were hoping to be able to take a little bit advantage of that as well, just as we did on STS-118.
Okay, our next reporter on the phone bridge is James Dean.
Hi, thanks very much, James Dean with Florida Today. So I think you've answered this, but just to further clarify, I guess, on the comparison with 118, not a mission that I covered, I take it you did not, the focus inspection determined there was no need to do anything further. So if Endeavor's 134's focus inspection confirmed the similarities that you're pointing out now, that would be your likely conclusion, was that it's cleared.
That's correct, James. Let me be specific. On the first part of your question for STS-118, we did, in fact, with the focus inspection, with the increased fidelity of the data that we derived from focus inspection, we were able to analytically clear the vehicle without doing anything beyond focus inspection. And as you saw in the pictures, comparing the on-orbit imagery to the post-landing, there's virtually no difference in the tile or the condition of the tile from when it was on orbit to after we landed, which says that we had a good analysis. At least in part, it says we had a good analysis. So in this case, we'll do, if necessary, we'll do the focus inspection. We'll get the additional data. It'll help the team have a little bit better fidelity on their analysis and probably allow them to be less conservative with the assumptions that they have in their analysis today, because they're making some conservative assumptions about the size, the dimensional aspect of this, if you will, where the damage site is concerned. And they could back off on some of that conservativism if they have better fidelity imagery with some better higher fidelity photography as well as laser data. So we would intend to then hopefully clear it analytically with some higher fidelity data. And in that sense, it would be similar to what we did on STS-118.
Okay, thanks. And I was wondering if there would be any more or just different concern on this mission, given that your late inspection is planned earlier and because you're giving away the boom. A few extra days, I guess maybe a couple extra days that area could be exposed. I mean, is there any issue at all with the timing of the late inspection after you've already identified damage that warrants a focus inspection?
No, not really. The two are pretty much independent in the sense that we're not going to leave these areas, and we're not going to leave this topic, and we're not going to give the boom away until I'm completely satisfied that we're not going to need it for anything else on this mission. So they're decoupled in that sense, and so we feel pretty good about the plan we have.
Okay, I believe that concludes the questions from reporters on the phone bridge. We'll turn here to JSC for some follow-ups. If we can start over here with Gina.
The Soyuz, when the Soyuz backs off and takes a photo, are those glamorous shots, or is there an engineering need for those photos?
Similar to this is the one thing that's similar to the plan we had for STS-133 is that there is some technical benefit to the photography operations that we're going to do. I think for station, station program itself, in addition to to include the partners and the vehicles that are resident at station now, they're going to get a vantage point that they perhaps have never gotten and is not easy to get. And so there will be some benefit from an engineering and technical data standpoint, just as there was then. There's less benefit because I think we're going to get overall less imagery because we're not doing a fly about or a fly around per se. But this is a whole lot better than no photography, and in fact there is some engineering benefit.
Seth Borenstein again. In terms of who's going to be operating the boom and the cameras, do you know that yet, or would?
I'm sure the team knows. I didn't ask for those details. We'll talk about that level of detail tomorrow if in fact focus inspection is still in the plan.
And in terms of the size of that, going back to sort of Post-it note size, a little bit bigger, slice of bread. I'm trying to think of
the damage site?
Yeah, the damage site.
I don't know how to describe it any better than to give you the exact dimensions that we're estimating it as. I've seen all different kind of size Post-it notes. There's really tiny little teeny tiny ones, and there's ones that are, larger. I'm not sure which Post-it note size you want to talk about.
Okay, no further questions here at the Johnson Space Center. We'll wrap up the briefing. A few operational notes. The crews are now in their sleep period. The shuttle crew is scheduled to wake up at 9:26 p.m. Central Time, the space station crew at 1:01 a.m. Central Time, and the spacewalk, the first of the mission, planned to begin at 2:16 a.m. Central Time. At the top of the hour, we'll be bringing the flight day highlights from today's activities, and that'll be running through the crew sleep period. We'll now return to Mission Control. Thank you.